Hello, my name is Jennifer and I'll be the academic coach leading this session. In this video, we are going to go over concentrations. We are going to learn how to use the equation to solve for each piece of information given. So to give us a little background information on concentrations is in a pharmacy setting we may be asked to solve for a concentration to a specific solution, cream, or ointment. Now these are different compounds. We also may be required to solve for active ingredient or maybe even our total. Now concentrations will be given in percent or ratio format. However, when we're working with our equation, we're going to work with percentages. One thing that we have to remember our golden rule here. The weight must be in grams and volume must be in milliliters. If we are given any other unit, we have to convert prior to using the equation. Also, your book gives you some information on how to identify what type of compound you're working with. So you're going to see something that looks like this. You have weight, volume, and then we have volume, volume. This is just for us to identify, well, do we have two solids, two liquids, or a solid within a liquid? Weight means that there's so many grams of active ingredient and so many grams of total compound. This means that there's two solids for this compound. Weight volume means that there's so many grams of active ingredient and so many mLs of total, which means that now I have a solid dissolved in a liquid. And for volume, this means that we have so many mLs of active to so many mLs of total compound, which means that now we have two liquids that are mixed together to produce that certain solution. This will also help us identify what units they would like our answer to be in if they do not clarify within the problem. Now let's go ahead and take a look at the equation. So we have A over T. A is for active, T is for total. We're going to multiply that by 100 and that's going to be the percent strength. Again, we have to work in grams or mLs only. The active and the total are both considered quantities. If we're given two quantities and once they are converted into the correct units, the low quantity will always be your active. So let's go ahead and take a look and see what that looks like. The first problem we're going to do is it says a doctor orders 800 mLs of a Zovirax solution which contains 200 mLs of Zovirax. What is the percent strength of the solution? So here, the first thing that we do when we see these problems is we're going to take a look at our units. Alright, I have a unit of ml as well as another unit of ml. That goes by my golden rule of grams or mLs only. So for this particular problem, we do not have to convert. So this is what it's going to look like. We're going to take our 200 mLs over our 800 because the low value will be our active. We're going to multiply by 100 and that's going to equal 25%. Let's now take a look at another problem where we may have to convert. So I have a technician is asked to make 60 grams of a hydrocortisone cream with 750 milligrams of active ingredient. What is the percent strength of the cream? So the first thing again I'm going to do is I'm going to assess my units. I have grams, so we're good there. We don't have to convert. But now I have milligrams. Can't have milligrams, I have to have grams. So I'm going to go ahead and convert my 750 milligrams to my grams. So I'm going to use my conversion factor. 1 gram is over 1,000 milligrams. My milligrams will cancel. So I have 750 divided by 1,000, so I have 0.75 grams. Now I can go ahead and set up my equation. My 0.75 grams is significantly smaller than my 60, so my 0.75 is my active. Multiply by 100. So when I put that into my calculator, 0.75 divided by 60 times 100, that gives me 1.25%. That is an example of doing a concentration problem where a conversion is required. Now let's take a look at an example of a problem where we're going to have to add two quantities together to get a total. So it says to prepare a topical cream, you add 900 milligrams of Cortef to 29.1 grams of cream base. What is the percent concentration of the cream? We have two solid medications, and the question is saying that we're adding two things together. So now our total is the combination of the two. So first I'm going to go ahead and assess my units. I have grams and milligrams. I'm going to convert my 900 milligrams to grams. So I have 1 gram is to 1,000 milligrams. My milligrams will cancel. I have 900 divided by 1,000 is 0.9 grams. The 0.9 grams is my active because this other quantity goes with cream base. That's not an active ingredient. So we have 0.9 grams. However, the question states that we're adding the 0.9 grams to the 29.1 grams. This essentially is 0.9 grams over 30 grams. Now we're going to multiply it by 100 and we get our percentage. So 0.9 divided by 30 times 100 gives me a 3% cream. That's an example of where we're going to have to add the two items together to get the total amount of compound. Now there will be keywords in the problem to tell us that we're going to do so. They can use we're going to combine, we are going to add, we are going to mix together. Now the only time that we're going to add when we get a total is when we're dealing with two solids or two liquids. If we have a solid dissolved within the liquid, we're never going to add those together. You can't add apples and oranges and get a total amount of apples. You can only add oranges and oranges or apples and apples. So they have to be the same in order for us to be able to add them together. Okay, now let's go ahead and take a look at an example where we're going to solve for the active ingredient, because so far we've solved for the percentages. Let's now solve for active ingredient because they are going to ask, well, how much active ingredient is contained? This question is specific to 400 mLs of 75% in volume and volume solution. This means that we have two actives. So they're giving us a total. So our active is going to be our X over 400 times 100 is equal to 75%. The only thing I did was I plugged my information into my A over T times 100 is equal to my percent equation. Now in order for me to solve for this, I'm going to turn this into a proportion, and I'm going to do that by dividing both sides by 100. So my hundreds will cancel. I'm going to rewrite this, leaving everything in fraction form so I get a proportion. Now that I'm left with a proportion, I can solve for x. I have 100x is equal to 400 times 75 is 30,000. I'm going to divide both sides by 100 to get x by itself, and I get x is equal to 300. My unit is going to be mLs because it's a volume. Now that we've solved for active, let's go ahead and now learn how to solve for total. Now we're going to be doing this in we're going to be doing this the same way that we solved for our active. However, our x is going to be in a different spot. So it says how many mLs of a 5% dextrose solution can be made with 4 grams of dextrose? So they're saying that I have 4 grams of active ingredient, so they want to know how much total could be made times 100 is equal to 5. I'm still going to set this up as a proportion, so I'm going to divide both sides by 100. The hundreds in the center will cancel. So we have 4 over x is equal to 5 over 100. I'm going to cross multiply, and I get 5x is equal to 400. I'm going to divide both sides by 5, and I get x is equal to 80. They're specific to a unit here. They're saying we're making a solution, so it's 80 mLs. Okay, so far in this video, you have learned how to solve for the percentage. We did examples where we convert. We've also done examples where we have to add two products together. Remember, they have to be the same unit in order for us to be able to add them. So we either have to have two weights or two liquids. We also learned how to solve for our active ingredient and solve for our total. Just remember, when working with concentrations as well as most calculations in the pharmacy setting, we have our golden rule of grams or milliliters only. Any other unit given, we're going to have to convert. I would like to thank you for viewing this video, and also thank you for choosing UMA for your education, and I hope to see you in lab soon.